Yeah. Good evening, everyone. Am I audible? Please, can you respond, please? Am I audible?
Yes, sir.
So get started. So what is the answer for the first one? So convex mirror gives an image 3 times as large as the object. So magnification is, so V is equal to 3U. Supplying the formula 1 by V minus 1 by U is equal to 1 by F. Placed at a distance of 20 centimeter from it. For the image to be real, okay, image to be real, V and U should have the same sign. 1 by minus 3U minus 1 by U is equal to, so V is 60, right? mistake. How can a convex mirror give a real image? V plus 1 by U is equal to 1 by F. So how much is the answer for this? One by 60 plus 1 by 20 is equal to 1 by F. So what is the value of F? It is 15 centimeter. If at all you have to directly calculate it, it is 15 centimeters. The question should have actually been concave mirror. Did anyone solve this?
Sir, convex cannot form real, that's right.
Sorry?
No, sir, convex mirror cannot form real image. Right, that's right.
There was a mistake. It should have been a concave mirror. But if at all you didn't follow the sign convention, answer would have been 15. So it's like you need to get marks for this.
Sir,
Tell me.
sir, image is 3 times as large as object. That means like they are talking about the size or the distance.
Size. As large அப்படின்னா large is size. As far அப்படின்னா distance. And actually the question should have been concave lens. Okay, because there are two things here. One is convex lens can't form a real image. Secondly, convex lens can never form the magnified image also. Okay. So there is a mistake, but still if you take it as a concave and solve it, you will get the answer as 15. So if at all you get an exam as concave mirror, I hope you understood how to solve it. Answer should have actually been minus 15 because UV will be negative for it. I'll just make a note of it. This part is 3, right? Nitish, did you understand when to take distance and when to take size?
Yes, sir.
Got it. So first question. Next. A convex lens of focal length 40 centimeter is in contact with a concave lens of focal length 25 centimeter. The power of the combination is. So P1 is equal to 100 by 40. Is it positive or negative? Power of the convex lens is positive or negative? So for convex, it is positive, concave, it is negative. So 2.5, and here it is going to be minus 4. So P is equal to P1 plus P2. Answer will be minus 1.5 diopter. Right. Did you understand why I wrote 100? Because focal length was given in terms of centimeter. Okay. Optical fibers are based on, obviously, total internal reflection. A plane electromagnetic wave of frequency 20 megahertz is traveling in free space along x direction at a particular point in space and time. The magnitude of electric field is 6 volt per meter. The magnetic field at this point is. So what is the relation, guys? What is the relation? C is equal to E by B, which implies since they told free space, C is 3 into 10 power 8 is equal to E divided by B. So answer will be B is equal to 2 into 10 power minus 8 Tesla. So here what is unwanted data? 20 megahertz is unwanted. Where does the energy reside in inductor when a current Ig is established in it? Obviously in the form of magnetic field. When magnetic flux crossing a given surface area held in magnetic field, when is the magnetic flux crossing a given area held in magnetic field maximum? Answer. When the area is perpendicular to the direction of magnetic field. When area is perpendicular to magnetic field, the angle between area and magnetic field will be 0 degrees. When electron jumps from the fourth orbit to the second orbit, what do you get? You get the second line of Balmer series. N is equal to 2, 2. Sorry, N2 is equal to 4 and N1 is equal to 2. The Bohr model of an atom assumes that the angular momentum of the electrons is quantized. What is the energy of photon whose wavelength is 6840 angstrom? So E is equal to hc divided by lambda, right? So how much will be the answer? So I just want to tell you something. Whenever wavelength is given in angstrom, right, and the options are asked in terms of electron volt, don't substitute H as 6.626 and 10 power minus 34 and all. Instead, what you can do is H into C itself can be written as 12,400. Okay, make a note of this. H into C in terms of electron volt and angstrom is equal to 12,400 electron volt into angstrom divided by lambda is 6840 angstrom. Please make a note of this point. So answer should be less than 2. Less than 2 na, it is possible is 1.81 electron volt. Guys, are you with me?
Yes, sir.
Yes, sir.
Did you make a note of this? This number 12,400 electron volt into angstrom. A particle of mass 1 milligram has the same wavelength as electron moving with a velocity of 3 into 10 power 6 meter per second. The velocity of the particle is. So electron moving with this velocity. So you can speak about the electron's velocity only in the case of de Broglie's wavelength. So lambda is equal to h divided by nb. So which implies lambda is how much? Oh, that's what we need to find. H is h only divided by mass of electron is 9.1 into 10 power minus 31 into speed is 3 into 10 power 6. And there is a particle moving with the, okay, this is equal to h divided by 1 milligram is 10 power minus 3, 10 power minus 6, no, sorry, 10 power minus 6 kilogram into the speed. H and H will get cancelled. Answer will be H is equal to, sorry, V is equal to 9.1 into 10 power minus 31 into 3 into 10 power 6. So how much is that? 27.3 into 10 power minus 20. 31 minus 6. How much are we going to get?
Minus 20.
Minus 20, no? No, but 25 is what I'm getting. But there is no option.
No, sir. There'll be 3 into 10 power 5, sir.
Which one, sir? Oh, I missed this 10 power minus 6.
Yes, sir.
That should be 10 power minus 31 only. But none of the options are matching. 1 minute. No. I made a mistake. It should be 10 power 12. 10 power 6 here. So 10 power 12 means, so minus 31 plus 18 is minus 13, no?
Sir, can you show the question? The velocity. Sir, I'm getting option C, sir.
option C is correct, but I'm just checking. Is there any calculation mistake in what I wrote? 9.1 into 10 power minus 31 into 3 into 10 power 6. This will go to that side as 10 power 6 only. 31 minus 12 is how much? Oh, 19. Oh, sorry. My mistake. So it is 2.73 into 10 power minus 18 meter per second. Okay. Which of the following particles has similar mass to that of protons? Obviously, neutron. What is the main source of energy from the sun? Answer. Nuclear fusion of lighter elements in the sun. In a wave, the path difference corresponding to the phase differences. Answer. Lambda by 2 pi into 5. Yellow light emitted by sodium lamp rings. Tell me that.
Sir, can you show the before question?
This one?
Sir, it's nuclear fusion. No?
Nuclear fusion. Sunnular fusion. Okay. Sun
Okay.
is fusion only, no? The helium, the hydrogen particles combine to give you the helium particles. Yellow light emitted by sodium lamp in Young's double slit experiment is replaced by the monochromatic blue light of the same intensity. Yellow light by sodium lamp in Young's double slit experiment is replaced by monochromatic blue light of the same intensity. Then what can you say about the fringe width? So what is the value of fringe width? Beta is lambda into capital T divided by small d. Beta is directly proportional to lambda. So since you are not changing the setup, what will happen to the value of beta? Lambda of which is greater than the lambda of the other. When you go from violet to red, what happens to the wavelength? Does it increase or decrease?
Increase.
Increases.
Increases means violet, indigo, blue, green, yellow, orange, red.
Yellow
So
will be greater.
lambda of blue. So beta of yellow will be greater than beta of blue, which is the right option. So it's replaced by monochromatic light. No, so fringe width should decrease. Correct? Did you guys understand this?
Yes, sir.
Is there any doubt? Okay, good. So two coherent monochromatic light beams of intensities I and 4A and superpose the maximum and the minimum possible intensities of the resulting beam are. Obviously 5I and I. Add them. The option is given as. Oh, sorry. So what is the value of maximum intensity, guys? What is the value of maximum intensity? Is it not root of I1 plus root I2 the whole square? You know this? So root of 4I plus root I the whole square, which will be 3I the whole square. Sorry, 3 root I the whole square will be 9I. Then what about the minimum intensity? I minimum is root I1 minus root I2. So that will be 2I minus I, which is going to give you I. Did you guys understand this point? The option is B. Is there any doubt of why this has come? If so, please let me know. Or else I assume it is clear. So can I confirm it's clear? Okay. For best contrast between maxima and minima in the interference pattern of Young's double slit experiment, the intensity of light emerging out of the two slits should be. should be equal. Best contrast means you need to have the best intensity present on the screen. Then if you consider both the lights to be of the same intensity, then the pattern will be more clear. Rectification is the process of converting AC into DC. In a P-type semiconductor, germanium is doped. Tell me now.
Sir, can you tell why it is AC to DC? Rectification.
Rectification, rectifier, what does it do? Rectifier converts alternating current into a flux.
Sir, it reduces the fluctuation, right?
கிடையாது. இது ஏசின்னு வச்சுக்கூடா. If you use a rectifier in between, okay, output வந்து you will get something like this. On the rectifier again there are two types. You remember half wave and full wave. Remember?
Yes, sir. Yes, sir.
So இது வந்து full wave க்கு, half wave வந்து you will get something like this. Negative half cycle will get swallowed.
Yes, sir.
So this is called as fluctuating DC. புரியுதா? So these options are given only to confuse. Low DC into high DC, obviously not possible. Low AC into high AC is possible only by a transformer. Okay. In a P-type semiconductor, germanium is doped. Obviously, you need to dope with a trivalent impurity. What are the trivalent? Gallium,
aluminum.
All three. All three, no?
Yes, sir.
In hydrogen atom, an electron undergoes a transition from second excited state to the. So read the question carefully. Second excited state means which orbit? See, this is where I've seen many people doing mistakes. Second excited state, now which orbit? N is equal to 1 is which excited state?
Ground state, right?
It is the ground state. So many of them read the second excited state and think that N is equal to 2. N is equal to 3. So in a hydrogen atom, an electron undergoes transition from second excited state to the first excited state and then to the ground state. Identify the spectral series to which these transitions belong to. Second to first another. It is Balmer. And when it comes to the ground state, it is going to be Lyman. What is it? It's Lyman series. Right? Find out the ratio of the wavelengths of the emitted radiation in the two cases. How to calculate? So first, what is the energy transition that is taking place? Delta E in case 1. Guys, can you speak, please? I'm not able to. You would have seen I have a throat issue already. I'm coughing continuously, correct? So please speak. Find out the ratio of the wavelength of the emitted radiation in two cases. So second excited state to first excited state in transition nadakumbodhu, what is going to be the energy conversion? What is the energy of ground state? Minus 13.6. What is the energy of first excited state? Minus 3.4. Correct. What is the energy of the third excited state? Minus 1.51. Correct. So case 1, it is taking place from N3 to N2. N3 to N2 nadakumbodhu, it will be minus 1.51 plus 3.4. So how much is the energy conversion? It is 1.9 electron volt. But they didn't ask the ratio of the energy. They asked the ratio of the wavelengths. So can I write this delta E is equal to hc by lambda? Because they are released in the form of electromagnetic radiations only. So delta E is 1.9. So when electron volt is there, I asked you to write hc in terms of what? Delta.
Sir, here final minus initial energy or we are not doing it?
See, it makes the same thing. No, I'm only calculating the difference in energy. Because anyways,
Then
if you're
fine. But usually we need to like calculate final minus initial, right?
that is for change. See, understand, when you're using the word change, it is always final minus initial. When you're using the word difference, now again, why you can ask me, sir, why did you find the difference? Because I wanted to find the wavelength. Okay, if I know the difference, however it is going to be, I'm going to write the energy only in terms of positive value because wavelength can't be negative.
Yes, sir.
That is the reason I found difference.
Okay,
Okay,
sir.
the get formula. Okay, I'll call this as 1 in vechukkonga. Delta E1 வந்து hc by lambda. So when you're writing in terms of electron volt, how will you write hc as? I told you already. It is 12,400 electron volt into angstrom, correct? Divided by lambda. If lambda வந்து 12,400 divided by 1.9 angstrom. Can I write it like this? Right. In a similar way, this is lambda 1 in vechukkonga. What about lambda 2? I'll get 12,400 divided by the energy difference between the second and the first. How much is that going to be? 10 point. So 13.6 minus 3.4, 10.2. So they ask the ratio of lambda 1 by lambda 2. Correct? So lambda 1 by lambda 2, can I write it as 10.2 divided by 1.9? Because see, lambda 1 is inversely proportional to 1.9. Lambda 2 is inversely proportional to 10.2. So 10.2 divided by 1.9 will give you how much answer? It should give you a value greater than 5. So it will be somewhere around 5.1. Are you guys able to understand this question? How many of you solved this? Okay. See, what are nuclear forces and give its important properties. So what is a nuclear force? It is basically a strong attractive force. First of all, it's an attractive force that is acting between protons and neutrons in the nucleus, which is the reason for them to get bound within the nucleus. Right. So when you talk about their properties, what will you say? Nuclear forces are going to be the strongest attractive forces. Secondly, they are short range forces. Third, they are independent of the charge. Fourth, they are non-central forces, means they do not act along the line joining the charges. Okay. So out of this, if you have written any two, you will get marks. An electron and proton are accelerated through the same potential. Which one of the two has greater value of de Broglie's wavelength associated with it? And secondly, which one has less momentum? An electron and proton are accelerated through same potential. So lambda is equal to h divided by root of 2m into ev. This is the reason. The reason I'm using this is because I have potential coming into picture. So when everything else is same, charge is same for electron and proton. So lambda of electron divided by lambda of proton will be equal to square root of mass of proton by square root of mass of electron. So which one is heavier? Proton. So answer will be greater than 1. So wavelength of electron is greater than the wavelength of proton. Correct, Ada? Then what about momentum? Lambda of electron by lambda of proton, you will have momentum of electron divided by, momentum of proton divided by momentum of electron. Lambda by lambda p is greater than 1. So momentum by this will be less than 1. So what will be the answer, guys? Momentum of electron is less than that of proton. sorry, this will be greater than 1 mole. Momentum of proton is greater than the momentum of electron. Define secondary wavelets. What are secondary wavelets? What are secondary wavelets? So when you have a wavefront, according to Huygens principle, every point on this wavefront will act as a source for the new disturbance, right? So if you take that wavefront and draw, if you take a point on the wavefront and draw a new wavefront, right? Then what are these wavefronts called as? They are called as the secondary wavelets, right? So having this concept in mind, how will you define it? So you need to define it like this. According to Huygens principle, every point on the wavefront acts as a fresh source for new disturbance, right? The new disturbance of those waves that are getting generated are what are called as secondary wavelets, and we have constructed them. So how can we construct a new wavefront? If you draw a surface tangential to the secondary wavelets, you get the new wavefront.
Sir, so we need to draw the diagram for this.
So they have asked how can we construct. No, you need not draw the diagram. If you have actually mentioned it, the tangential surface to the wavefront, that's enough. I drew the diagram for you to understand. Ram, are you clear? State to position in which a concave mirror produces a magnified image of the given object. Tell me that. One is when the object is placed between the center of
Pole and focus.
pole and focus is virtual image. What is other case?
Focus and center of currents.
One is here, one is here. So list the two differences between these two images. Obviously, one will be real,
Virtual and
second one will be virtual. And obviously, second point is real images are inverted, virtual images are erect. Correct? Got it?
Sir, between C and F, it will give real, right? Real.
It will give, yes, yes. Except between F and P, everywhere else it will give you a real image.
Yes, sir.
So the reason why between F and P it is giving a virtual image only, it is mainly used in shaving mirrors. That is the biggest advantage with concave. Because you go between focus and pole, right? You can see an enlarged image of yourself.
Okay, sir.
Yeah. Answer 24. This is something that has to do with the memory. Which of the following electromagnetic wave has minimum wavelength and minimum frequency? Write one use of the following. So out of the four that are given, which one has the minimum wavelength?
gamma ray.
Because it has maximum energy.
Yes.
Then what about the minimum frequency?
Microwave.
Correct. What are the uses of each? Infrared waves. They told one use. No, infrared. Where do we use?
Sir, we
Use it
should
in
give only for that microwave and gamma ray.
See, write one use for each of these two waves. Oh, only for microwave and gamma. Okay. Anyways, we'll discuss infrared. What is there? It is mainly used in remote control. Microwave, you can use it in ovens. What about gamma rays?
Cancer treatment.
Yes, cancer treatment, you can use it. And what about X-rays? Scanning purpose?
Sir,
Right.
gamma rays, where are we using?
Cancer treatment. That is cancer treatment.
Okay.
Next. Draw energy band diagrams for pure semiconductor and insulator. When you draw the energy band diagram for a pure semiconductor, what is the bottommost band called as? It's called
Valence
as
band.
valence band, and this is called as the conduction band, right? For an insulator, what is going to, sorry, for the semiconductor, what is the energy difference going to be? It will be less than 3 electron volt. Whereas for an insulator, it will be greater than 3 electron. Correct? That is for the first one. How does the energy band for pure semiconductor get affected when its semiconductor is doped with acceptor impurity? So what will happen then? How does the energy band for pure semiconductor means extrinsic semiconductor, get affected when this semiconductor, sorry, pure semiconductor, intrinsic semiconductor, get affected when the semiconductor is doped with acceptor impurity. When it becomes an intrinsic semiconductor, what will happen?
Sir, acceptor impurity means trivalent, right?
Trivalent. Simple, when you add a simple as ultima, what they're asking is when you add a trivalent impurity, what will happen to the pure semiconductor?
Whole concentration will increase, right?
Yes, that's it. That's what they're expecting. That is a keyword. It becomes a p-type semiconductor, correct? So holes will increase. Concentration of holes will increase. When you dope it with a donor impurity, what will happen? Concentration of electrons will increase. That's it. Hence, discuss why the holes and electrons respectively become the majority charge carriers in these cases. So obviously, you know the reason.
Sir, for the before question, like for the holes, we need to draw the energy band gap.
Not needed. Not needed. So why the holes and electrons respectively become the majority charge carriers in these two cases? So you can explain that theory, right? When you add a trivalent impurity, what will happen? 3 electrons from the trivalent impurity will combine with 3 electrons from the semiconductor. The fourth electron does not have any combination to get paired. As a result of which, what will happen? You will have deficiency of electron, which is holes. In a similar way, what happens to electrons in the case of adding donor impurities? When you add donor impurities, they are pentavalent impurities. So out of 5, 4 will get combined with the neighboring particles and 1 will be left free, so that you have excess amount of electrons. Okay. So for more details, I'll send you you will get the solution sheet. You can have a look at it. Draw the ray diagrams for a concave mirror showing the formation of an object placed anywhere in front of the mirror. For a convex mirror. So for a convex mirror, if you place the object anywhere in front of the mirror, what will happen is rays, one ray goes like this, the other ray comes like this. So this will be AB and this will be A dash, B dash. You get a virtual and a diminished image. Use this ray diagram to obtain the expression for its linear magnification. You know what you're supposed to do, right? You'll take 2 sets of similar triangles, right? and then find the magnification. So when you find the magnification, you'll get V divided by,
Sir,
so you get, tell me that.
sir, ray striking the pole should retraces its path, right?
It retracing what you know. If this angle is theta, this angle is theta. Retrace kadayada, it will bounce back symmetrically with respect to the principal axis. The retrace
Sir,
will
when
happen at the center of curvature. Retrace will happen through the center of curvature. Purida.
okay.
Oh, no, I'll tell you. See. Let's explain it quickly. The center of curvature, now, when the ray is traveling like this, the angle of incidence is how much? What is the angle of incidence?
90.
0. 90
Sir,
kadaya, 0.
how, sir? Like tangent, if you
So
draw.
tangent oranja, that is a mistake again. Angle of incidence is measured with the normal, not with the tangent.
Okay. 0, sir. Yeah.
Adanaala it will retrace the path. Okay. Next, compare the interference pattern obtained in the Young's double slit experiment with the single slit diffraction pattern, pointing out 3 distinguishing features. See, these are all important questions, sir. I hope you have answered it. So this is there in your textbook itself. So when you observe the intensity pattern for Young's double slit experiment, the intensity will almost remain the same with distance. Whereas with respect to a diffraction pattern, what will happen is the intensity keeps decreasing like this. So this is there in the textbook. Have a look at it. Or you can say distance also. This is distance. This is intensity. Okay. Okay, now they're asking any 3 distinguishing features. Can you tell me what are they? So
Equal
first,
with unequal fringe width.
okay.
Then we can say about the central fringe width is less bright than central fringe
But you have
width.
already told in the first point, Lara. Unequal is okay. Yeah, please continue. Can you speak in terms of intensity? Have the graph the same, no?
Okay.
All the bright fringes have same intensity in
Yeah,
the case
yeah,
of intensity.
they all have the same brightness.
Same.
Central bright fringe.
For diffraction?
Diffraction for
Correct.
the central fringe is more bright than the others.
Very good. Correct. Similarly, interference, when do you have it? Interference, you have 2 different sources, right, which we call as coherent sources. Whereas for diffraction pattern, it is
We can have any source
from the same way. It is from the same, only one source. From the same source, it is called as self-interference. So generally, when you talk about interference, light comes from 2 sources. Whereas when you talk about diffraction, light comes from the same source. It is we who are giving an explanation to it, because the pattern is like looking like interference. That is why diffraction, we say, though we have a single wave, that light coming from a single wave, right? So superposing of the wave on itself happens in the case of diffraction. So these are the 3 differentiating factors. 28. Define the term wavefront. Wavefront is basically the locus of all points which are vibrating in the same phase. Next, state Huygens principle. So Huygens principle mainly speaks about the secondary wavelength. Every point on the wavefront acts as a source for fresh disturbance. Right. So the tangent drawn to those fresh disturbances gives you the new wavefront. Third, consider a plane wavefront on a thin convex lens. So you have a convex lens. On this convex lens, let's say there is a plane wavefront incident. So plane wavefront means where are the rays coming from? The rays are coming from infinity. So when the rays are coming from infinity, where is the image formed? At the focus. So if you take this to be the focus, this is how the wavefronts will look like. Okay. So shape of emerging wavefront will be spherical in nature. Next. Describe 3 experimentally observed features in photoelectric effect. What is it? From the experiment, what are the conclusions we drew? One is threshold frequency. One, we speak about threshold frequency. Second is about the consideration of maximum kinetic energy. And thirdly, we speak about no time lag. That is, as soon as the photon of sufficient energy is incident on a metal surface, electrons get emitted out in less than a nanosecond. Okay. Second is, this is also an important question. Why wave theory could not explain the concept of photoelectric effect? First thing is, it could not account for the instantaneous ejection of electrons. Okay. Secondly, it didn't account for the threshold frequency. It did not explain. Wave theory doesn't speak about threshold frequency. Third, according to wave theory, kinetic energy depends on the frequency, but according to experiment, kinetic energy is independent of intensity. So these are all the reasons.
Sir,
Tell me that.
sir, can we also say like atoms cannot observe energy continuously and can be observed only in quantum, like discrete packets?
Yeah, that
So,
also you can say. You can say that, but these are the 3 points that are given in textbook. Let's follow that.
sir,
Let's
in
go.
textbook only it's given, I think.
These are the 3 main important points. Come again, what is the point?
Sir, since
Energy cannot be absorbed.
observed continuously, in case of photoelectric,
Absorbed as சொல்றீங்க. Absorbed
observed,
தானே?
yes, sir.
Absorbed. AB தானே? ABSORB.
AB, yes, sir.
Absorbed. Okay.
So, in
But,
photoelectric, the intensity, on increasing the intensity, the energy observed by the electrons on the surface of metal will increase and
increase.
they will overcome the.
அதுதான் இந்த point. அதுதான் நான் சொல்றேன். Kinetic energy. That is why I told, according to wave theory, kinetic energy depends on the intensity because of the same reason that you're saying, because of the continuous absorption that is taking place. The point that
Okay.
that is why I told kinetic energy is independent of intensity. When we do the experiment, you remember we get kinetic energy independent of intensity. That is why they told what are the observations from the experimental aspects of photoelectric effect. So experiment பண்ணும்போது what are all the things that you observed is what they are asking. So Ritesh, we both are speaking the same thing.
Sir, what is the third one under the photoelectric effect, sir?
Iduvada?
Yes, sir.
No time lag. Means
Okay.
as soon as the photon of a metal surface, as soon as the photon hits the metal surface, you can see that the electron will get ejected out in less than a nanosecond. That is the meaning. So these are the factors for which wave theory could not account for, because wave theory completely has a different story to tell us. So since they didn't match only, photoelectric effect cannot be explained with the help of wave theory. So as I told you, from exam perspective, this is a very, very important question. So please read this. See, this is a derivation again. You can refer to the video. The first part is again a derivation. So what will be the power of the combination? P will be equal to P1 plus P2. Second, a ray of light passing from air through an equilateral glass prism undergoes minimum deviation when the angle of incidence is 3/4 of the prism. So when I take the prism, it is the incident ray. Minimum deviation means what happens? The refracted ray will be parallel to the base. So how much is this angle? 60 degrees. So what is the angle of incidence? Angle of incidence is 3/4 of 60 means 45 degrees. So if angle of incidence is 45, angle of emergence will also be 45. Calculate the speed of light inside the prism. So how to calculate it? So what is the value of refracted ray? Here it is angle of refraction will be 30 degrees. Correct? Because R is equal to A by 2. I hope everybody knows this happens in the condition of minimum deviation. Okay. So if I take this to be the refractive index, sine 45 is equal to mu times sine 30. So what is the value of mu? It will be root 2. When mu is root 2, mu will be equal to speed of light in vacuum by the speed of the light in the medium. So root 2 is equal to 3 into 10 power 8 divided by V. So V will be 3 root 2 by 2 into 10 power 8. That is 1.5 into 1.4 into 10 power 8. So this should be 1.5, approximately 2.1 something into 10 power 8 meter per second. Okay. Next. Two independent monochromatic sources of light cannot produce a sustained interference factor. What is the reason for it?
Sir, two independent
Because
monochromatic sources don't have same phase difference. That's it.
means basically they cannot be coherent. They are not coherent is one of the reasons. What you told is right. So what is the meaning of coherence? They should have the same frequency and they say constant phase difference, right? So they are not going to be coherent. And secondly, what will you say?
They are not superimposed each other.
See, the same point can be explained like how we told. You can say that they are not coherent. Okay. And two sources cannot two independent sources cannot release waves continuously. Okay.
Sir, for interference,
So
superimposing should take place, right?
superimposing should be. Come again.
Two waves should superimpose. That's when interference pattern can be observed.
That is what we think. Actually, what will happen is you will have a single source. Okay. In reality, what they do is single source is there. No. That single source is actually split into two sources. so that this wavefront and so that the rays coming from S1 and S2 are going to be coherent. So what we think is there are two different light sources. No, you will have only one light source, but you will place a cardboard in between with two holes so that the one light source is actually getting split into two different parts. So these wavefronts actually go and fall on each other to give you the interference pattern. That is the meaning. Purida.
Yes, sir.
So light waves, each of amplitude A and frequency omega, emanating from two coherent sources of light, superpose. The displacement of the two waves are y1 is equal to a cos omega t and y2 is equal to a cos omega t plus phi, where phi is the phase difference between the two. Obtain the expression for the resultant intensity at point. Oh, resultant intensity at the point. So how to get it? Y is equal to y1 plus y2. It is going to be a cos omega t plus a cos of omega t plus phi. Right. If you take out that a outside into cos omega t plus phi will actually give you I don't know what happened. Which question was that? Huh? So it will be 2 cos of 2 omega t plus phi divided by 2 cos of phi by 2. Okay. Now, this 2 times a cos phi by 2 can be taken as capital A into cos of 2 omega t plus phi the whole divided by 2. Okay. Now, what is going to be the amplitude of the resultant? Amplitude of the resultant will be 2 cos phi by 2. So, what will be the intensity? Intensity is equal to k times a square. So, k into a square is 4 cos square phi by 2. So, that will be the answer. So, it will be 4k a square cos square phi by 2. This is going to be the intensity of the resultant according to the waves that they have given. In a Young's double slit experiment using monochromatic light of wavelength lambda, the intensity of light at a point on the screen has a path difference lambda, where the path difference is lambda is k units. Find out the intensity at a point where the path difference is lambda by 3. So path difference lambda corresponds to a phase difference of how much value? Guys, tell me. Path difference of lambda corresponds to a phase difference of how much value? Phi is equal to lambda by 2 pi into p. Sorry. Phi is equal to 2 pi by lambda into p. So what is the path difference? P is equal to lambda means phase difference will be 2 pi. Now what are they asking? The path difference is lambda by 3. Then what will be the phase difference? 2 pi by 3. So take this value and substitute it. So 4k a square into cos of 2 pi by 6, that is pi by 3, or cos square pi by 3. 4k a square into cos square pi by 3 is 1 by 4. 4 and 4 will get cancelled. K a square should be the answer. So this will be the correct answer. When a light is when a surface is irradiated with the light of this much wavelength, the photo current appears, which vanishes if a retarding potential greater than 0.6 volt is applied across the phototube. When a different source of light is used, it is found that the critical retarding potential is changed to 1.1 volt. What is the work function of the surface and the wavelength of the second source? If the photoelectrons are subjected to a magnetic field of 10 Tesla, what changes will be observed in the above two retarding potentials? How to solve this? When a surface is irradiated with this much wavelength, a photocurrent appears, which vanishes if retarding potential greater than 6 volt, 0.6 volt is applied across the phototube. When a different source of light is used, it is found that the critical retarding potential had to be changed to 1.1 volt. What is the work function of the metal? So what is the photoelectric equation I should write? Can I write H nu is equal to W naught plus K max? Or it is W naught plus K max is E times V naught. So what will E times V naught be equal to? H nu minus. So this is where we have the work function. So first equation, E into V naught is how much? 0.6 is equal to, this I can write it as Hc by lambda minus W naught. Can we calculate the work function from this? In the place of H into C, I will write it as 12,400 divided by lambda is 4950. 0 and 0 are gone. Minus W naught. So W naught எவ்வளவு இருக்கும்? 1240 divided by 495. 1240 divided by 495 minus E is 1.6 into 0.6. So 1240 divided by 495 into this value. So on calculating this, work function should give you a value of 1.9 electron volt. So once you get work function as 1.9 electron volt, again you will write the second equation. So E times V naught is equal to Hc by lambda 2 this time minus W naught, that is 1.9. So Hc by lambda 2 is equal to EV naught plus 1.9. E is 1.6 into 10 power minus 19 into the new V naught is how much? 1.1. 1.1 plus 1.9. So solving this, lambda 2 should come out as 4.125 into 10 power minus 7 meter. .14. So this will be the wavelength of the light. Next, what are they asking? If the photoelectrons are subjected to a magnetic field of 10 Tesla, what changes will be observed in the retarding potential? Okay. So basically, if you observe in the electromagnetic radiation itself, electric field is a dominating factor. So all these things are happening because of electric field. So when you eliminate with magnetic field, nothing will happen because magnetic field cannot control the kinetic energy. They can only control the direction. Nothing will happen to the retarding potential because they don't control the kinetic energy. They control only the direction. Okay. So two more questions, we'll finish it. A compound microscope is an optimum for magnifying image. Okay. Magnifying power of a compound microscope is defined as ratio of the angles perpendicular. Okay. All those things are fine. Consider the compound microscope that consists of an objective of focal length 2 and an eyepiece of focal length 6.25 separated by a distance of 15 centimeter. The object distance for eyepiece so that the final image is formed at the least distance of distinction. Answer: 1 by VE minus 1 by UE is equal to 1 by FE. So 1 by the final image is formed at the least distance of distinct vision. So you'll write it as minus 25 minus 1 by UE is how much? That's what we need to find, is equal to 1 by FE is 6.25. So 6.25 is going to be 25 divided by 4. So 1 by UE is equal to 25 by 4 minus 1 by 25. So 625 minus 4 divided by 100. It is 621 divided by 100. That is 1 by UE. So UE will be 100 divided by 621. Oh, I'm sorry, it is 4 by 25. Four by 25. So it will be 3 by 25 is 1 by UE. 3 by 25 plus plus, no? It will be 5 by 25, which implies UE is equal to 5 centimeter. Similarly, how far from the objective should an object be placed so that in order to obtain the condition described in part 1? So V0 will be equal to, so I'll apply 1 by U, sorry, 1 by V minus 1 by U is equal to 1 by F. 1 by V0 minus 1 by U0 is 1 by F0. Okay. So V0 is going to be 10 centimeter because UE is 5 and the distance between the lengths is 15. So 15 minus 5 is 10. So 1 by 10 minus 1 by U0 is equal to 1 by 2. So 1 by U0 is 1 by 10 minus 1 by 2. So it is 5 by 10. It is minus 4 by 10 is 1 by U0. So U0 will be minus 2.5 centimeter. Answer is 2.5 centimeter. What is the magnifying power of the microscope in the case of least distance of distinct vision? It is V0 divided by U0 into 1 plus D divided by FE. V0 is 10, U0 is 2.5 into 1 plus D is 25 divided by FE is 6.25. So this should go 4 times. This is 5, so this goes twice. 20 should be the answer. The intermediate image formed by the object of the compound microscope is obviously real, inverted, and magnified. Fifth one, the magnifying power of a compound microscope increases with last one. Are you guys even listening?
Yes, sir.
Yes, sir.
So how to do this one? When light from a monochromatic source is incident on a single narrow slit, it gets diffracted and okay, all these things are okay. Actually, when they asked you about the difference, you could have taken the idea from here. You could have written the answer from here. In a single slit of width 0.1 millimeter is illuminated by parallel beam of light of wavelength 6000 angstrom and diffraction bands are observed on a screen 0.5 meter from the slit. The distance of the third dark band from the central band is how much? Answer. So what are all the values given? D is 0.1 millimeter, lambda is 6000 angstrom, capital D is 0.5 meter, right? So for third dark band, what is the condition? D sin theta should be equal to 3 times lambda. Right. What about Y, guys? Right.
Sir, the D should be sir, should the D should be in the other way?
D should be in the
The distance n lambda D by D.
this is wider. This is capital D. N lambda into what are you saying? I'm not able to understand.
N lambda capital D by D, right?
That's what you're saying. Okay. N is 3. Lambda is 6000 into 10 power minus 10 into capital D is half divided by small d is 0.1 into 10 power minus 3. So how much is answer coming to? I'm cancelling this and this, it goes 3000. So 3 into 3, 9 should come. 9 millimeter is what I'm expecting the answer. Is that right? Is that right? 9 will be the answer. 9 millimeter will be the answer. Next. In front of a diffraction pattern, slit width of 0.2 millimeter in the screen placed at a distance of 2 millimeter away from the lens. If the wavelength of light used is 5000 angstrom, then the distance between the first minimum on either side of the central maximum is. So what will be the answer? If this is the center, where is the first maximum formed? So what will be the distance? 2 lambda into capital D by D. Right? This is where the first minimum is formed. This is where the first minimum is formed. Lambda into capital D divided by D. And this is also lambda into capital D divided by D. It will be 2 times lambda into capital D divided by D. So substitute the values. What is the answer? So 2 into lambda is 6000 into capital D is 2 divided by 0.2 into 10 power minus 3. This will go 0.1 times. So 6000 into 10 power minus 10. So 600 into 2 into 10 power minus 7. Did I miss anything? There is nothing related to 12.
Sir, the wavelength is actually 5000 lambda, not 6000.
Oh, 5,000. Okay. I took the previous value. So 5,000 means how much I'm getting upper இது correct. இது வந்து 500 வச்சுக்கோ 500 into 2 1 should be the answer. Which one is right? It should either be A or B. So previous one 9 I guessed it, but here we have to solve and see. So 1000 into 10 power minus 7. So that will be 10 power minus 4. 10 power minus 4 never. 10 power, this is 10 power minus 4 meter only. 5,002 into, wait, let me do it again. Come again. So 2 into 10 power, 2 into 5,000. 2 into 5,000 into 10 power minus 10 into capital D is how much? 2 divided by 0.2 into 10 power minus 3. This is 0.1. So as I mentioned, 0.1 into this is 500. Solra.
Sir, the value of wavelength is not given in angstroms, sir. They are simply given as 5000 lambda.
That is what I doubt. I'm not sure. See, generally, if they give in terms of 1000, it is angstrom. If they give in terms of hundreds, it is nanometer. With that guess, I
Okay.
proceed. So 1000 into 10 power minus 7. Now 10 power minus 4 தான் வருது. 10 power minus 4. Not sure what is getting missed. 10 power minus 4 is
Sir,
not there.
if you keep it as 5000 alone, like 10 power minus 1, it's coming.
5,000 which are 10 power minus 1 varda. But the answer given is 10 power minus 2 da. I have to validate whether that is correct or not.
Sir, I got 10 power minus 2 only, sir, by keeping 5000.
Are you able to observe, is there anywhere I went wrong?
Sir, if you keep it as 5000 lambda, we are getting the answer.
Sorry, 5,000 for your satisfaction. It should not come different. Sorry, 5,000 into 10 power minus 10 is the into 10 power 3 into 0.1 into 2 evlo avudhu 0.2 that is 2 into 10 power minus 1
Sir,
correct,
where
correct.
is 10 power minus 10?
There 10 power minus 10. I didn't disturb it. You asked me to keep 5,000 as it is, no?
Yes, sir. Where did it come from? 10 power minus 10.
From the angstrom. Nada solrene. See, if they give wavelength in terms of 1000, it is always angstrom. If they give wavelength in terms of hundreds, 700, 753, adala on the nanometer.
Okay.
Okay. So 5,000 into this is 10,000. 10,000 at 10 power 4. So 10 power 4 into 10 power minus 10 into 10 power 2. Up 10 power 4 into 10 power minus 6. Sorry, minus 6, minus 8. I'm still getting 10 power minus 4 only. Okay, I'll sure that you'll get marks for this. Niranjan, how did you get 10 power minus 4?
Sir, I didn't consider that 5000 to 10 power minus 10, as you said, that if they given thousands means take it as 10 power minus 10, that angstrom, sir. I didn't consider
Okay,
it as
anyways,
angstrom.
that itself is a mistake. Okay, that's fine. I'll ensure that you get marks for this. 10 power minus 4 தான் வருது. So, understand the difference. Next time onwards, be smart. 100 la kudutha nanometer, 1000 la kudutha angstrom. Is incident normally on a slit of width 0.2. The angular width of the central maximum, the diffraction pattern is observed. So how do you calculate angular width? Please speak fast. Go to spelling badly. How do you calculate the angular width of the central maximum?
2 times lambda by d.
How much? 2 times lambda by a, correct. So 2 into lambda is how much? 600 into 10 power minus 9 by a is how much? 0.2 into 10 power minus 3 So this will go 0.1 times 60 into 10 power minus 6. 6 and this should be the answer. A diffraction pattern is obtained by using the beam of red light. What happens if the red light is replaced by the blue light? So tell me, how is the fringe width related to the wavelength? Directly proportional to wavelength. So lambda of blue, lambda of red. Tell me what happens. Lambda of blue is less than that of lambda of red. So what will happen to the width when blue light is used?
Decreases.
What will happen?
Net.
Which one is the right option? Bandwidth decrease fringe width decrease how will those two rays be? Will they be closer?
Band will disappear.
Band disappear. Look at the fourth option. No? Diffraction bands become narrower and they become crowded.
Yeah, okay.
Got it? Yeah. So to observe diffraction, the size of the obstacle is. This I have told in the theory itself. The diffraction pattern gate is very, very important. For you to observe diffraction, the size of the obstacle should be comparable to the wavelength of light. So option B is the right answer. Sariya? Remember this. That is where the whole concept of wave optics comes from. The size of the opening should be comparable to the wavelength. Right? So, just to conclude the story, you will get marks for 2 questions. One is the first one and 35th second part. Okay. Right. There are no more doubts. We can wind up.
Thank you, sir.
Yeah, thank you.
Thank you.
Thank you.